Hey everyone, welcome to Delete Your Search History. My name is Tom Gleitzman, I'm a solutions architect, and I'm joined by Principal Solutions Architect Brian Leonard and Principal Developer Advocate Karen Yulme. Today we have a very special session for you. It's going to be an interactive workshop showcasing how you can build out full text search on top of your MongoDB applications using Atlas Search. So if you're a developer who's focused on the how can I provide my users search capabilities quickly and intuitively, then this is going to be the perfect workshop for you. Additionally, if you've never developed anything like this before, don't even sweat it. We're going to make this really easy to follow along. The inspiration for today is a search bar, something that we use every day in learning, in entertainment, shopping. For me personally, whenever I'm developing and I need to troubleshoot my code, I prefer search to picking up a book or leaning on my colleagues for help because, well, search is easy. It's flexible, it's powerful, and it's available at my fingertips. Many of you may have used search to find this very video, and I'm really excited to be able to share with you how you can provide your users with a similar experience with just a few button clicks and a little bit of code. So today we're going to be getting hands-on with building out basic full text search queries with relevance-based scoring, adjusting to typos using fuzzy matching, highlighting and autocomplete, all while building out multiple different facets and filters across multiple different data types. And the three things we're going to need is a MongoDB account so we can leverage a free tier M0 Atlas cluster, a web browser so we can access our Atlas environment as well as a hosted coding environment, and some basic knowledge around JavaScript since that's what our application is going to be written in. So I'm going to jump straight into provisioning this cluster. We're going to navigate to mongodb.com, and then I'm going to click on sign in the top right corner. From here, if you already have a MongoDB account, I highly encourage you to sign in and spin up your own M0. If you don't have an account, or if maybe you forgot how to provision your own cluster, don't even sweat it. I'm going to be walking you through those steps right now. So we'll click on sign up, and then we'll fill out the form that it prompts us with. Password, phone number, my company name is MongoDB. My job function is a solutions architect. I'm based out of the United States. From here, I'm good to sign up. Now, while our account is being built, we're going to be prompted with a few different options as far as naming an organization and our project. In the grand scheme of things, this doesn't really matter. So I'm going to name my organization MongoDB.Live 2021. I'm going to name my project Atlas Search Tutorial. From here, I'm good to continue. Now we're faced with a few different avenues that we can go down. For what we're doing with Atlas Search, we can do all of this on a shared free tier cluster off to the right. So I'm going to click on create a cluster on the rightmost column. And you'll see that now we have an Atlas configuration page. Here we're faced with a combination of cloud providers and regions that we can spin up a cluster with. I'm going to select AWS in North Virginia. However, feel free to choose any combination that you're most comfortable with. My cluster tier, I'm going to keep at M0. And my additional settings, I'm going to keep to the default. My cluster name, I'm going to change to Search Tutorial. And I'm going to go ahead and create my cluster. So now our cluster is being provisioned. I know that I'm going to want to be able to interact with Karen and Brian and allow them to collaborate with my cluster. So in the top right, in the project setting, I'm going to click Invite to Project. And here I can type in their email addresses. So I'll add Brian to the project. And I'll add Karen to the project. From here, I'm going to give them different capabilities. So instead of project read-only for them both, I'm going to give them both project owner access. And then invite them to the project. So while our cluster is provisioning, I want to be able to provide the method to the madness here. Right now, I'm showing you how to provision the backend platform, which is Atlas. And then after our infrastructure has been provisioned, we're going to load in some sample data. After that, I'm going to hand the baton off to Brian, and he's going to take that sample data and show you how to build out a back-end search API. And in the latter half of the workshop, Karen is going to show you how you can take that search API you built and integrate it within a front-end application. So we're going to go from this. It's going to be a Netflix clone skeleton that has no search capabilities. So if I were to type in a query, it doesn't do anything because there's no backend hooked up to it and there's no sample data that I can serve to the application, to something like this, which is going to be a full-fledged web application that has MongoDB Atlas Search running on top of a sample data set. So if you see, if I were to type in a query, autocomplete starts to take over. I already even misspelled this query. Instead of typing in Superman, I mix up the N and the A, and I serve that query. I still get the result set that I'm looking for, sorted by its relevant score. So if I were to look at the documents, the highest rated score is going to be Superman Doomsday with a score of 12.18. And even here in this document, I can check out the description of it and see that I have highlighting enabled. So I can see exactly where in my description my query matches. And it's matching on Superman twice. All we're going to need to be able to accomplish this is this bit.ly link. So this bit.ly link will route you to a hosted coding environment in CodeSandbox.io. So if you were to type in bit.ly/search live, search live is going to be case sensitive. You'll see that all the code that we need to be able to follow along is going to be available to us right here. And additionally, in the chat, we're going to paste in a document that contains the text that outlines every step we're going to be taking along the way. So traditionally, when customers would build out full text search capabilities within their applications before Atlas Search, they'll need to manage two separate data stores, and this comes with its pain. Whenever you insert or modify or delete a document within Atlas, you need to synchronize that change to an Elasticsearch or a Solr in real time. And really the magic behind full text search comes from Apache Lucene. And Apache Lucene is going to be an open source, highly performant full text search engine. And what we've decided to do is integrate that directly within the Atlas ecosystem. By doing that, we provide you with native full text search capabilities on top of your MongoDB data without the need to manage an entirely separate data store and without the need to define your own synchronization process coming outside of Atlas. And so now let's go ahead and check on our cluster and see if we're ready to load in some sample data. I'm back here and it looks like our M0 is ready to go. I'm going to click on the ellipses right here and I'm going to click load sample data. And this is going to load in roughly 350 megabytes worth of data that we can use to build out that backend search API. From here, our backend platform is pretty much ready to go. I'm going to hand it off to Brian, and he's going to show you how to build out that backend search API now. You got this, Brian.
All right, thank you, Tom. Now that we have the backend deployed, I'm going to walk you through creating the search API that Karen is going to use to plug in to her front end. So specifically, we're going to start by creating the search index. And we need to do that before we can search against the data. Once the search index is created, we're actually then going to define our search query against that index. And then we're going to wrap up this section by creating the microservice that has the API endpoint that we're going to share with Karen. So let me jump on over back into the Atlas cluster that Tom created for us. And here is our search tutorial. And so we left off where you should have loaded your sample data. I'm going to go ahead and click this collections button here and take a look at the sample data that was loaded. And you can see we provide a wide array of data for you to work with to get accustomed to MongoDB. Specifically, for this tutorial, we're going to be looking at the movies collection in the sample NFIX database. And so just quickly, if you were to select that collection, you can see there are about 25,000 movies in here. I'm currently looking at the first 20 of those. If you click this expand arrow here, you can kind of see a fully fleshed out record that represents a movie. And so where we want to begin, as I said, is actually creating the index that's going to allow us to search against these movies in a rich way. And so you'll notice that there's the traditional MongoDB indexes that you may be familiar with. And those are B-tree index, standard database indexes. We're actually going to create a search index based on Lucene that's an inverted index. This is more of like the index you have at the back of a book. And this is going to allow for that rich text search that we're looking for. Now I can get there by clicking here or here. It's going to take me to the same place. And so I'm just going to go ahead and click search indexes. And you'll see we get a nice summary of all the great things that search is going to provide for us. And Karen's going to go into some of these later, like autocomplete and so on and so forth. But for now, I just want you to click the button that says create search index. And you'll see that Atlas offers us a couple of paths, a nice visual editor that we're going to use today, as well as a JSON editor. So go ahead and stick with the visual editor and click next. And then we need to give our index a name. We're going to stick with the default name. And the benefit to this will be that when we actually call the index, we won't have to tell it which index to use, because it's going to look for the default index. And so what I want you to do is leave the name default and then go ahead and make sure that the Sample Inflix Movies collection is selected. That is the collection that we want to index in this case. And go ahead and click next. And now you've got some other tunables that we can get into. And as Todd mentioned, our search capability is based on top of Lucene. And so the default values that you're going to be presented are going to use the Lucene standard analyzers. However, it's completely tunable. You can click this refine index button down here and you can change the analyzers. Another real powerful aspect of this particular index we're creating is the dynamic mapping. And so what's really nice about this is that it's going to index all of the fields in our collection. And even as that collection evolves over time and new fields get added, they will get added to the index automatically. You don't have to worry about it. So this default solution is a really nice one to get started with. So without really making any additional choices, go ahead and click Create Search Index. And so once you do that, this is going to take a couple of seconds. And so the index is actually created asynchronously. And so it's going to take a moment here to kind of kick off. And you see now it's just switched to not started. And pretty soon the index will start to create. And then in this case, for the 25,000 records, it only takes a couple of seconds to actually complete. And so we'll sit here and wait for that completion to occur. While that is happening, let me explain a little bit about what we're going to do next. We're going to go back into the collections tab, go back to where we were looking at our movies collection, and we're going to start creating the query to use against this index. And so there you go. Our index is complete. We're not going to test it now, so you can close this dialog. And as I said, you can see it's currently active, 100% complete. I want you to click back on the collections tab and navigate your way back to the Sample Inflix Movies collection. And this time we're going to jump to the aggregation tab. And so the way we're going to query or activate or use this index is through the aggregation framework. And there's a new operator in that framework called search, a new pipeline stage. And so I can click the aggregation tab. And if you haven't seen this aggregation pipeline builder before, it's extremely powerful. And so I'm using it for search, but there are in any scenario where you're working with aggregations, I highly recommend it. And essentially how this works is the tool is showing me on the right a picture of my documents that are in my collection. And aggregations in MongoDB are a series of stages that feed into one another. And so I'm going to go ahead and, for example, I'm going to start with, and you can just start typing, I'm going to start with the search stage, and it gives me some basic examples of what I could do with this stage. And what I'm going to do instead is Tom shared with you a code sandbox. And as part of that code sandbox, we included some snippets that I'm going to use in this portion of the tutorial. So slide over to your code sandbox and open the snippets folder. And I've numbered these. So the first snippet we're going to work with is the ag search. And so go ahead and select this value, copy it, slide back over to Atlas, and you can just replace the entire selection with that value. And essentially what we're doing here is we're querying, we're doing a text search for zombies against the plot field. And so you can see the solution or the search came back with movies related to zombies that we can begin to work with. And so as a next step, you can see we've got a lot of fields here in our collection, and they're kind of overwhelming me. I don't want to see all these fields. And so as I mentioned, I can feed this stage of the pipeline into a future stage. And so I'm going to go add a new stage, and I want you to go ahead and select this time the project stage. And here I'm going to switch back over to my snippets, and you'll see the second snippet is project. And I'm really just interested in these 5 fields. And so just like before, go ahead and paste that in. And you'll see our output now is a much simpler 5 sets of fields. I can see my top zombie movie is now Dead Snow 2, Red vs. Dead. And the other thing you'll notice that's kind of cool is there's a new field that I don't have up here, which is the score field. And so basically what Atlas Search is doing is based on the criteria we provided, it's coming up with a relative score of how relative are zombies to this particular record. And it came up with a score of 3.9. And it sorted the documents for me by score. So this top document is the most relevant. And so not only can you search against a single field, but it's also possible to search against multiple fields. And this is extremely powerful. And so you see up at the top where our path is plot. What I'm actually going to do is if you go back and look at the third, and you can either select the whole thing again, but really what changed is just the path value. So I'm going to select just these 3 in my case. And I'm going to come in and I'm going to replace the plot with this array of fields, or at least I thought I was going to. I really screwed that up. Let me go back. Let me just type it in. No, actually, let me go back. And we're going to copy. And there we go. That's better. And so now we've told the search engine to actually execute the query against plot, full plot, and title. And in doing so, it actually came up with a slightly different set of movies, meaning when you told me to look at these additional fields, I came up with a better set of movies for zombies, at least relatively to that search term. So you see this particular movie, Cockneys versus Zombies, was the top score. All right, so let me show you another really cool aspect, and that's as we're doing our standard Google searches, it's very common to misspell something, and we love the fact that it kind of knows what we're thinking and gives us what we want anyhow. Well, Atlas Search has the same exact capability, and it's through a feature called fuzzy. So I'm going to go ahead and just type it in this case because it's pretty straightforward. I'm going to put a comma, and I'm going to type just fuzzy, and then there's additional tunables you can provide to this fuzzy, but we'll just go with the defaults for now. And then let's go ahead and do a search on, say, Indiana, one of my favorite movies, Indiana Jones. But I've mistyped it, and I accidentally just forgot the J, and I've got Indiana Owns. Well, because we did a fuzzy search, it didn't matter. You see the results still came back with Indiana Jones and the Temple of Doom. Pretty cool, right? So the last thing I want to do before I wrap up this section is just limit the results to, I know my front-end developer, Karen, only needs 12 records for her application, the top 12. And so it's really important when you're running these search queries to not bring back more data than you need. So I'm going to go ahead and add a third stage to my pipeline. Oop, I think I clicked that twice. I did. So I'm going to delete one. And just a simple limit stage. We'll do limit, and I only want the top 12 records. And so there we go. And so now that all of that is done, one of the coolest features of all of this is I can actually export this pipeline code to a language. And remember, my ultimate goal here is to create an API that my front-end developer can use. And so let me click this export to language. And you see we have a handful of languages that are supported. And I'm going to select Node. And I'm going to go ahead and copy these values. And don't worry if you didn't copy it. I have it saved for you in my snippets to use later. So I'm going to go ahead and close this down. And then I'm going to move on to the next step of creating this API. And to do that, I'm going to take advantage of Realm. And we could spend an hour talking about all the greatness that Realm brings, but I'm going to give it to you as one way to think. I like to think of it as just kind of like Node.js as a service. And so where you would typically host your own Node.js server, with MongoDB Atlas, you don't have to. We host it for you, allow you to code functions and so many other things in there. And so since I want to bounce back and forth, rather than just go right into Realm, I'm actually going to right click it and open Realm in a new tab. And I'm going to switch over to that tab, and it's going to welcome me to Realm. And Realm is actually, we're going to create like a hosted Node.js application. And so I'm going to call this application Netflix clone. It doesn't matter what you call yours. I'm going to link it to my data source, which is the cluster that Tom created. It's the only one I have to choose from, so that's nice and easy. And I'm going to create my Realm application. And so, as I'd mentioned, there's a ton you can do with Realm. It's going to offer you these guides. Go ahead and close these. If you ever want to get back to them, they're right up here. So by all means, I would encourage you to do that. And you see there's this large menu on the left of things we can do in Realm. Again, extremely powerful. We're going to do one simple thing, which is create a third-party service. And so I want you to go ahead and click that menu item. And then we currently don't have any services, so I'm going to add a new service. And you can see there's multiple service types supported. We're going to create a generic HTTP service. And let's just call this the movies service and add it. And then our service can have one or more webhooks. These are the endpoints that I'm going to share with Karen. And there's only one in our case, the search one. And so I want you to click the add incoming webhook. And we're going to call this get movies. Now there's all kinds of authentication options and logging, and the only other thing I need you to change on this particular page is the HTTP method, and I want you to change it from a post, the default, to a get, because we're getting movies. We can leave all the other defaults here, and then I want you to scroll back up to the top and switch over to the function editor. And here's where the real power lies in this third-party service that we're going to create. And so I'm going to slide back over to our snippets, and you can see I've got this search function. And I'm going to go ahead and select all of this and copy it. And I know it looks complex, but I'm going to walk you through it. And we're going to slide back over, and I'm going to select all of this, delete it, and paste in the function that I just copied. Now, the bulk of this is the query that we just created. So ultimately, this is obviously pretty easy. It starts off by grabbing our search term. And so again, this is going to be an endpoint. It's going to have a query argument. That query argument is going to be our search term. I just want to go ahead and grab whatever term that is, whatever Karen's app is looking for. And then we're going to get a handle to the movies collection, the same one that we were working with a moment ago. And then finally, here's our search query. Remember we exported that a moment ago? Well, here it is. And the only difference is where we had a hard-coded, I think it was Indiana owns, the misspelling. I've just replaced the query with the search term that's going to be passed into the function. Otherwise, you can see we've got our 3 stages to our pipeline. We're going to run the search stage against the plot, full plot, and title. We've got our projection and we've got our limit. And then we're going to wrap this function up by actually calling the aggregate function against the movies collection, or against the movies collection. And we're going to pass it our search query. And we're going to send it to an array. That's going to be the output from this endpoint. And so with all that being done, go ahead and click Save Draft. And then once it's saved, you have to publish it. So again, you have to deploy it. So click the Review Draft and Deploy. And you can view all this if you want. Those are all the changes that occurred, but go ahead and deploy that change. And once that's done, click on the Settings tab, and our webhook URL now has a proper name. And I'm going to go ahead and show you, we can test this out in our browser really quick, just since it's a simple HTTP GET. And so I'm going to go ahead and copy this URL. I'm going to open a new tab. I'm going to paste the URL in, and I'm going to pass in that argument. So I'm going to add $arg equals, and let's say we're looking for movies about sports. I'm going to go ahead and type that in, and boom, I've got it. It's not pretty, but this is 12 JSON records of sports related movies. And with that, Karen, I'm going to pass this endpoint over to you for you to pick up the baton and keep the ball moving.
Hi, everyone. And thank you, Brian, and thank you, Tom. Now I get to do the fun part, because everything they provisioned, downloaded, indexed, aggregated, and exposed by an API, I get to use that API from the front end and take that movie data and put it inside of our Netflix clone. So if you're following along in the code sandbox, Brian was copying, pasting, using the snippets from the snippets folder. I'm going to be doing something very similar, but I'm going to be taking snippets from the front end snippets folder. And then I also have, when we create a webhook later, you'll also find that in the webhooks folder. I really like Code Sandbox, but as a developer, I really prefer working with Visual Studio Code Editor. So that's what I'm going to be doing for this, because I'm just more comfortable with it. But you could see here in the directory that we have all the same folders and files that you have in your Code Sandbox. So let me just walk you through. I have it running in live server on this half of the screen. Inside of this index.html, I have some basic CSS inside the head. And then inside the header, my logo is found inside the public folder. And then my search bar is a simple HTML form of input type text. And then when we submit that form, we're going to be calling the search movies function, which we're about to build out in a second. I have two divs in here. I have an autocomplete div that we're going to be using for auto-completed movie titles. And I have the movie search results div here. Now inside of my JavaScript, all I do here is I grab a handle I get all those elements by ID and create variables for that. And in my search movies function, I have a string, and when I hit enter, it's going to put that string on my screen. So if I look for movies about vampires or anything, there you go. I hit enter, and there's our welcome to delete your search history. This is great, not terribly practical, but the API is practical. So let's put that to use. If you're in the snippets, go to the search movies.js, grab that, and we'll replace this entire function here. So the first thing I did is I made it asynchronous. Because we're calling an API, I'm going to be using async and await for that. My text string is empty. My search term is anything inside of that search bar. And then my webhook. Let's get that webhook that Brian gave us. If you created your own, this is where you'll put it. And then my URL, just like Brian showed you, I'm going to append the search term to that webhook here. And then inside my try, I'm going to use the fetch API to get the data back from the URL, convert it to JSON, and those will be my movies. I'll just console log it here into the console. So let's see what happens. I'm going to look for movies about Indiana Jones. And let's have a look and see what we got. So the first thing that looks really good is that I see that I have 12 documents here. So remember how Brian said limit 12? These are those 12 movie documents. And if I open this up, I have Indiana Jones and the Last Crusade, Indiana Jones and the Temple of Doom. I have the plot and the poster and the score and the title for all of these. So this is great. This means that my front-end application can call the API and get the data. Now all I have to do is take the data out of the console and put it onto to our web application, which seems easy enough, but there'll be a few hiccups and I'll point them out to you and we'll work through them together. So now that I have my movie objects as an array, I'm going to iterate over that array. Give myself a little more room here again. So for each of those movies, I'm going to get a variable for the title, the plot, the poster. And then here for my text, I'm using a template string. I'm using backticks to create a template string to create all of those HTML elements that I have, the image and the div. And then I can embed these variables inside of that template string with the $ and the curly brackets here. So let's see how this works. I'm going to look for movies about soccer. It's a new soccer team in Austin. So this looks pretty good because I have my poster and I have my title, but the score and the year, it's not really what I want. I see my plot, so that's great, except for the score and the year. It says object, object all the way through. And then at the end, I'm getting my posters back, but in this last movie, I don't have a poster. The reason I don't have a poster, it's not in the database because some of the documents won't have posters. But I will show you why we're getting object, object for score and year. And the reason is because you see here that the score and the year are indeed objects. So the score is number double, it's an object, number double and a very long number, and year is number int 2001. So the reason this happens is because MongoDB stores data as a BSON. So this is great because you can store so many rich data types beyond simply JSON. But as a front-end developer, I just want the year to be 2001. So how do I do that? I'm answering this question here because we get it a lot on our community forums, and I used to struggle with it a lot, and I would fix it, and then I would forget how I fixed it. I'd have to ask Brian or Tom or my friend Nick Raboy. So I'm just going to show you my new secret sauce, something I discovered and I don't forget about it. If you go to object values, that little code snippet, we'll paste that in here, starting with poster. Oops. Okay, so first thing is, let's go ahead and look at poster. So I use this, if poster is inside the movie document, that's going to be my poster. I use this ternary operator. But if it's not, then I have this link to a statically hosted PNG that I'm hosting inside of an S3 bucket. Now, for object object, to deal with that, I use object values, which is easy to remember because I just want the values out of the object. So year, I'm doing object values, movie year, and score, I'm doing object values. I'm converting it to a string and I'm slicing off the first 5 characters of it because remember, my score is actually really, really, really long here and I don't want all of that. So let's see what happens when I do that. Again, I'm going to do soccer. And there you go. I have my score. I have my year. Everything looks pretty good there. And then if I scroll to the bottom, I have my movie poster. So this looks great. Let's do another one real quick. We'll look for movies about zombies. I always look for movies about zombies. So now I have movies about zombies. Remember, so I can see zombie in the title here. I can see zombie in the plot. And remember when Brian was talking about relevance-based scoring. Relevance-based scoring means that we're looking for zombies, the term zombies, across the plot, full plot, and title. And the movie documents that have those terms in it the most frequently across those fields will have the highest scores. And here we get the highest scores first, so they're the most relevant ones. This brings me to something I really want to show. I really, really want to show. And when we're planning the workshop, I actually asked Brian for this. I want to show highlights. So I asked Brian, can I please get highlights back in the payload? And he said, no, you may not. Actually, he didn't even say that. He just said no. And that was the end of the conversation. but it's very easy to do and it's very quick to do. So I'm just going to show you really quickly all he had to do to give me highlights back in it. I'm going to go use Compass, which is our graphical user interface. I like working in Compass a lot. This is hooked up to Brian's collection. And if I do aggregations here, one of the reasons I really like working with Compass is because, I'm going to clear this out. The reason I like working with Compass is because not only can you create the aggregations as Brian did inside the Atlas interface, but you could save them. So I'm going to open up Brian's aggregation here. And as you see, same aggregation, querying for Indiana, owns across plot, full plot title, project, limit, and then the preview. Now, all Brian had to do to make me happy, which he would not discuss with me, was add this very simple highlight object here. Format that correctly. So once we put in highlight and we say what fields we want it in, I just want to get the highlights back from plot. Now Atlas Search is going to calculate the highlights for all of the movie documents, which means it's going to find Indiana Jones, fuzzily matched of course, in its proper context. Now, in addition to letting it calculate it, I need it projected out to me. So just as Brian used the meta operator inside of project to surface the metadata for the score, I'm going to do the same thing to surface the metadata for highlights. So highlights, meta, search highlights. Now, if we look inside our highlights array, we can see, let me move this a little bit, and I'll see if I can make this bigger. So if I'm going to open this up, you see that highlights is an array. And in the array, we only have one element because I'm only looking across plot. If I look across title or full plot, I'd have more elements. But inside of that object, I have another array of text. And inside of that, I have value, which is the words inside of your plot field. And they can be either of type text or they can be of type hit. So the interesting thing to me as a front-end developer is that I can look to see if it's a text or a hit. And if it's a hit, I can just highlight it or make it bold. And if it's a text, I don't have to. So with that, now that I know this aggregation works, let's grab the code just like Brian did. This is all he had to do. And I'm going to go back to his webhook. So this is his webhook. Now I'm going to change his webhook. And hope he doesn't get mad at me. Let's see, so I have that. That looks right. The end here, and then remember to change this to the URL parameter here. So we'll save this. Deploy it. And then now, the same API that we had, we make that one simple change. And let's get the highlights back. So I am going to, inside of movies for each, I'm going to create a new variable, plot with highlights. So instead of being plot here, I'm going to return plot with highlights. And then you see that this variable has to call another function. And that function is build plot highlights. If you're following along, go ahead and grab that out of the front-end snippets folder. And what this function does, very simple. I have an empty string, and then it is going to iterate over that highlights array that we have. And every time it goes in that highlights array, it's going to iterate over the text array. And if it's a hit, I'm going to make that value red. And if it's not, I'm just going to return the value. And I'm going to add those onto the string as we go. I'm going to append those onto the end of the string. And that's what's going to be returned to the front end. So now let's try this again. See if I get my highlights. Gosh. There you go. So now I see zombie is what we're looking for. Zombies is what we're looking for inside of the plot field. It's in red, it's easier to see, and it's going to show me why these movies are really more relevant and why they were returned first. So that wasn't so hard. Was it, Brian? That's all you had to do. But anyway, so now that's basically all you have to do for this web application, but I wanted to show you it doesn't look like a Netflix clone yet. The rest is simply styling. So I'm just going to go back here. I have the style sheet inside of the public folder. I'm going to uncomment that. And so now we'll look for movies about, let's look for movies about Harry Potter. There you go. There are all my Harry Potter movies. I have the scores in them. I have the highlights in them as well. So this is great. I want to show something else. I was talking about questions that are asked in community. We get a lot of questions asked about how do you do autocomplete. It's actually kind of simple, but there are a few sort of tricks to get started. So let's go ahead and I'll show you some of those things, and then it'll be easier to build from there. The first thing we'll do is let's go back to the data inside of Atlas. So here's our cluster. Brian created this index here. So I'm going to create a new index for autocomplete. Visual editor, we'll keep using that. And I'll name it autocomplete. Sure, it's my, yep, movies next. Now, Brian mentioned that he was mapping everything dynamically. This is great when you have small data sets, maybe not a lot of fields, because it's going to take all the data, and as your schema evolves and changes, it's going to take that data and add it to your index. But as your data grows, you might find that you have really large collections, and you might have hundreds of fields inside of every document, but you might only care about a few fields. So if you're mapping everything dynamically all the time, you're going to take a hit in performance. For autocomplete, I only want to index one field. So I am going to refine my index, and I'm going to turn off dynamic mapping. And the field that I want to use is title. Now, anytime you add fields to an index individually, when you're refining it, you have to tell Atlas Search what type of data is inside that field. So it could be string, it could be object ID, number, object ID, date, number, GeoJSON data. Autocomplete will always be autocomplete. So let's put in autocomplete. We have all these tunables here. I can turn off dynamic mapping here, and I'll save the changes and create the index. Now, this shouldn't take too long. So let's go back to Compass. It's only 23,000 movie documents. And let's open this up in a saved pipeline. Okay, great. So you see here that since I have documents in the right, that means my index is already built. It's already indexed those collections. So I'm using autocomplete. A couple of things I want to point out the difference. Because it's not default, I actually have to say the index. So it's index autocomplete here. Next, instead of using text, I'm using the autocomplete operator to query for Harry inside of the title. So, and then in project, I'm just getting back titles with Harry here. Now, the other thing I could do is, just as Brian did, I can also add fuzzy matching here. So I'm going to do fuzzy. And then now you see that instead of getting Harry all the time, I have Mary here, and I can get all sorts of different types of versions of Harry. Brian used the default max edits when he didn't specify the fuzzy object. The default is 2. I'm going to do 1. It gives us typo tolerance, but not as many degrees of typo tolerance. So I'm going to save that. I can grab that code here if I wanted to. But actually, I have the whole thing built out already in the autocomplete titles. So let's be like Brian, and let's create a new webhook inside of his service. So I'm going to call this one autocomplete titles. I'm going to make it a get. These are the same things Brian did. And inside my function editor, let's take all that out. And if you want to grab the code for autocomplete titles.js inside the webhooks, and we'll just paste that in here. Okay, so just as the other webhook we did, we have the search term from the payload query, handle to the movies collection. Here is that aggregation, and we just run that aggregation on the movies collection. Save it. Deploy it. Okay. And then now, let's grab that webhook URL and bring it back to the front end. Give ourselves some more room here while we build this out. Okay, so at the bottom, after build plot of highlights, I'm gonna in the webhook before I lose it. Now, I want to, so what we want to happen inside the application is, we want to, as we type everything in here inside this box, I want to hit that API. So I'll type in Harry, I'll get some results. If I type in Harry P, I'll get different results. So I'm going to add an event listener to listen for input on that box on the search bar. So search add event listener, it's going to call the function search movie titles. And then you can grab that function. Inside that function, it's going to be just like we did for search movies. It's asynchronous. I have the search term, and then the autocomplete URL is going to be that webhook that we just created. So let me paste that in here. And then my buddy Nick Raboy would yell at me if I didn't have this line in here. So that we don't hammer the API all the time, I want to make sure that I have at least 4 characters before I start calling that API, and that's what this is. If I've typed in at least 4 characters, I'm going to call that using fetch. I'm going to call the autocomplete appended with our search term. And for all the titles I get back, I'm going to map over them. I'm going to create an element, a div for each one of them with the title in it. I'm going to add an event listener onto that div, and which we'll call fill movie title. I'll show you that in a second. And then for all of those divs, I'm just going to append it to the end of everything I have inside of the autocomplete area of the web page. Now, function fill movie title is very simple. It just means that once you clicked on one of those divs, it's going to fill that title into your search bar, and then it's going to call the search movies function that we had earlier. So since we're calling that function earlier, I need to modify that one a little bit to have it clear out our auto display. So once it gets called, we can do that. So let's save this. Give myself a little room to flex, I guess. And then let's look for a Rocky movie. Actually, let's look for Rocky 2 because it's the best Rocky. So there we go. We have Rocky 2. We have all the different Rocky movies. I have autocomplete. If I wanted to do movies about zombies, I can just do that. There I get zombie movies that I had before, and I have autocomplete. I have highlighting. I have all these great things. You have it running here in your Code Sandbox or locally. The other last thing I want to show you for this application is a way to host these files. This is a very simple application. And if you wanted to share this application with other people, you can simply go back to our Realm application. You see hosting here on the left menu, and I will enable it. Great. Now, there is a simple boilerplate HTML index.html file in there. I'm going to overwrite it with the one that we just wrote. Upload. And the only files I need for this application to work is that index.html and our public folder, because it has that SVG, the logo, and the CSS. So it's uploading the files. Okay. So now I'm deploying, and it says it's going to take 15 minutes, but it's not going to take 15 minutes because it's pretty simple. When we're ready, when it's cooked, it's going to be here inside of this URL. So we're going to come back in a second and go through that, see how that URL is doing. So if we go back here, we did everything we wanted to do. Provision the backend, built the APIs or two, and we used it from the front end. So if you manage to stay with us this whole time, that's fantastic. If not, you have that document that you could follow with screenshots at your own leisure. You have the sandbox that I created. And then this is a sandbox search live finished that has the completed application. So you can go through that. The interesting thing here is that you can sort of compare and build as you go. I hope you learned a lot from this. I hope it inspired you to keep trying. If you wanted to keep trying and keep building and you're ready for that next level, or if you're just curious about what's going on, there is this What's Cooking application that I have. I showed it in the keynote demo yesterday, where we search across all sorts of different data types. It's written in React and Tailwind. And if you wanted the GitHub for it, you can do search What's Cooking. So let me show you that application really quick. Here it is. So let's say if I wanted to look for Italian. So this is a map of New York, and this marked on the office is the MongoDB office inside of New York. And so the data that is running off of is restaurant data. So as you can see, I can query across different numbers. So let's say I want to have at least 3-star restaurants. I want to have it Italian. I want to make sure it has soup on the menu. So you can see I have autocomplete here if I'm going across the title. If I want to do menu, I can do that. I can filter, do all sorts of filters for the types of restaurants or for the boroughs, whatever. So if I want to do GeoJSON, I'm going to look for that here across close to work. And if I wanted to make it even closer to work with GeoWithin, this is a sphere. So I get everything inside of there. And then you can see also if I open up menus, I have soup inside the menu and I'm highlighting. But the interesting thing is not just that the application works, but when you start playing around with these filters, with these search building blocks, as I call them, you could pop open the aggregation button with a push there and you could check out the code. So this is the code that all those work. So you can see that I'm using text, fuzzy, I use GeoWithin here, all these different ways of using it. I use range to get 3 stars or more and highlight. I can also play around with function score. So this is a really cool way of playing around with data there. So you're welcome to download it, play around with it, and then we have it hosted as well. And the other thing is, let's check this application. Remember, go back here to hosting, and that's where you'll get it. There you go. So now all your files are hosted, and you could look for Rocky movies or Harry Potter movies or whatever it is that you want. And you built all of this. We did a whole bunch in this workshop. I hope you guys learned a lot. I hope you guys had fun. I know it might possibly be overwhelming, but take your time with it. We are here for you if you have questions. We're here afterwards. And then don't be afraid to talk to us inside the community forums as well, because we're really looking forward to seeing everything that you built with it. So on behalf of Tom, Brian, and myself, thank you so much for coming, and talk to you soon. Bye.